Hello and welcome to the 43rd session of the ARCA AI Safety Reading Group. Today I'll present the blog post Strong AI Isn't Here Yet by Sarah Constantine. Sarah Constantine is a PhD from Yale in mathematics and has a blog called Otium where she's written this article that Strong AI is not here yet. This article is from the 21st of February this year. That makes it a lot more relevant. A similar article from 10 years ago would be reasonably meaningless. She prefaces it with epistemic status moderately confident, which is something many rationalists do to indicate whether it's just idle speculation. The thesis of this blog post is bigger and better deep learning systems, but not fundamentally different from those which exist today, will not soon become capable of general intelligence. Here, the word soon is within 100 years, and general intelligence means human-like. So, with what counts as a fundamental breakthrough? Sarah Constantine mentions neural networks as an important breakthrough, and the backpropagation, the algorithm that made it perform properly, as major breakthroughs, whereas minor breakthroughs are things like long short-term memory and convolutional neural network and neural Turing machines. I've looked up when these things happened, and 1958, 75, these are a long time ago, whereas the minor breakthroughs are much more recent. It's important to realize that she's not claiming that strong AI cannot be done. She's not claiming that it will not be developed with conceptual breakthroughs. There's also, you can't infer from what she's writing that narrow AI might not be a very big deal. And she's of course not trying to malign the accomplishment of people who work on deep learning. She's just claiming we're not done yet. The article starts with a fundamental observation about the question, does probability extend logic? Meaning, can you model all logic with probability theory? And this is a controversial position. And Sarah Constantine links and seems to accept David Chapman's refutation of E.T. Haynes, who claims that indeed probability does extend logic. So there is some kind of controversy here that Sarah Constantine doesn't really accept. And I must say right off the bat, I am hopelessly biased in this discussion because I think of myself as a rationalist, and rationalists positively adore E.T. Haynes. So there's two ways to look at a problem like this. There is the outside view, where you look at this kind of arguments. How do they normally roughly work out? The other is the inside view, where you look at the arguments itself. And I'm obviously much less smart than either David Chapman, E.T. Haynes, or Sarah Constantine, so I can't really evaluate the arguments in the inside view. So instead, I'm going to present the outside view in a somewhat unsympathetic way, if only to say, to show that Sarah Constantine, who just accepts David Chapman, that might be very controversial. After I've presented the unsympathetic outside view, I will continue with the assumption that probability theory does not extend logic. So the outside view, this is basically an argument from authority, which is often a fallacy, but often is also not a fallacy. So we have David Chapman and E.T. Haynes opposed to each other. E.T. Haynes describes himself as a Buddhist engineer, a scientist, he hasn't published anything though, and a pop spiritual philosopher, and has a book, Meaningness, which isn't actually about probability theory in any way. It's just a couple of pages in the appendix. E.T. Haynes, professor of physics at Washington University, has written an article called Information Theory of Statistical Mathematics with more than 10,000 citations, and Probability Theory, the Logic of Science. This book, which I happen to own, has 5,000 citations. So I think it would be fair to say he's a much more established person. And the tone that David Chapman uses to dismiss E.T. Haynes is extremely negative and somewhat superficial, claiming just that he's completely confused and confused by very, very, very simple things, and should be supposed to be very obstinate about this. I hope from this is not a full proof, of course, but I hope from this it's clear that in most cases where there is this kind of disagreement, very often the establishment turns out to be correct. So now we'll assume that probability does not extend logic, and in this case we are going to talk about logic and how to look at logic. And there are several ways to slice the cake to look at logic. One is there are several orders. The lowest, the 0th order logic, is called propositional logic. These are where you have some claims with and, or, not, if, this kind of thing in between them. Very, very simple. The next level, 1st order logic, also called predicate logic, where you add things like for all, or there exists, or and predicates that a kind of function that returns a truth value. Another way to look at logic is through ways of reasoning. There are two main kinds of reasoning: inductive reasoning and deductive reasoning. Deductive reasoning is what Sherlock Holmes does. Like, you know that A implies B, and you know A, then you logically conclude that B must be true. Inductive reasoning is much more about probability theory and priors, and so it's something that suggests truth but does not ensure it. And the key here is that deductive reasoning that humans can do, it depends on predicate calculus, on predicate logic, and not just on propositional logic. And while as propositional logic is an extension of probability theory, we are now assuming that that predicate logic is not an extension. That probability theory is not an extension of predicate logic. So here we have the circumstance says that assigning probabilities to claims in predicate logic, that's an unsolved problem. We don't know the link between probability and predicate logic. When we try to do it, we quickly run into things like the ontology problem. Here, you have if you want to put a probability on the sentence "all men are mortal," then you run into the question: what are men and how many men are there? Over here, I have a picture of an ontology of the world of ice cream, and to show these categorizations and different ways of looking at it. This is what ontology is. There are two other things that are important to look at. There are percepts. A percept and concept. A percept is a cluster of data points that are similar in some way, in the way that one of the most common ways to use a neural network is to do image classification, where you look at, for instance, have a number of images. Some of them are of cats, and you want to have a classifier that determines which are of cats. And if they are similar in some way, all cats are similar in some way, that's a percept. A concept is a kind of a percept that behaves properly under ontology changes. So this means that now we're suddenly talking about not just images, but video clips or sounds or descriptions or something that are from a different way of looking at the data. And we don't know how to implement concepts in AI, and that's required to learn predicate logic statements. So this means that because we don't know how to assign probabilities to sentences in predicate logic, then we cannot deduce things, objects, and concepts and work with that in a deductive way. Humans, of course, can do it. So this means that obtaining human-level general artificial intelligence, that seems to require solving an unsolved problem. Okay, neural networks, that was what the original thesis was about. Neural networks are, in fact, probabilistic models, because a neural network is a simplification of a Bayesian probability model, and just one that's a lot easier to work with. And we don't know how to assign and update probabilities in predicate logic using Bayes nets. So neural networks will also be unable to transform predicate statement into probabilities. It might happen by itself, you might object. It might be possible that deep neural networks will figure out a way to represent concepts by itself without humans teaching it how to do it. It might happen by itself. Sarah Constantine believes that this is very unlikely, because in order to work with concepts, we need to understand them on an algorithmic level, and we don't really know what concepts are. And Sarah Constantine explicitly says this, and this claim that you can just push a lot of computing power on a difficult problem and then it will solve itself is something that we have very poor experience with so far. That is the reason why Sarah Constantine believes that we need a conceptual breakthrough before we will have strong AI. Thank you for listening, and see you again next week.